Welcome to the OpenHPI course Linked Data Engineering. This is lecture number 5, Linked Data Mashups and Applications. In this first part of the lecture, we will talk about how to publish linked data. You know, the web of data is the web of the available datasets, the linked open datasets, which are interconnected datasets of structured data encoded in RDF and accessible via HTTP. We have talked about that and you have seen this picture quite often in this course. The web, just let's recapitulate that, the web of data contains more than 9,000 or almost 10,000 datasets. There are represented about 150 billion facts in it, and there are about 800 million links among these datasets. So you can learn more statistics about this huge web of data if you access one of these URLs. Either you go to stats.lot2.eu or to lotcloud.net. There you can find current statistics of the actual size of the web of data. Now, possibly you want to make your own data also part of the web of data. What do you have to consider? We have already heard about these linked data principles. So these are 4 basic principles, which means first, when we want to name things in our data, we should use URIs. And of course, we should use HTTP URIs, which means people should be able to look up these names on the web. And of course, if they look up these names on the web, these URIs, there should be useful information provided, like, for example, information encoded in the RDF standard, which can be queried, for example, with the SPARQL query language. And what makes linked data most useful is, of course, that each data or each data set, of course, is interconnected, is linked to other data sets. This means any entity, any URI might be linked to another URI and might have a relation to another entity in another data set. And this is what makes things interesting. So you can discover more information, you can discover more things. The more links you have to other data sets, the more information you provide about your own data. And this makes it even more useful. So let's try to consider these principles when we want to publish our own linked data. But what's the benefit of using linked data? We have already talked about this in the very first lecture. So you don't have to rely on screen scraping to get any data from the web. If you have already available linked data, this means your information can be dynamically aggregated from external and publicly available sources. And then, of course, you do not need a specialized API, application programming interface for that. You can do this always via the generic linked open data interface, which means all your data is encoded via RDF. You will be able to look up the vocabularies that have been used to encode that data and what they mean. And of course, each of the data will be available via a simple HTTP request. So this is really an open and generic interface. And this, of course, is a huge benefit. And if you dynamically aggregate this data and then compute something and provide the result again as a dynamically aggregated or generated data as linked data, this means your data will always be up to date without manual interaction. Since if the data, that is the basic data that you are using, changes, your dynamic application, for example, will use the change data immediately as soon as the change really happens. And this means data is always up to date without any additional manual interaction. Of course, these are huge benefits which lower maintenance costs, and this, of course, is a big issue. Okay, so how do we now publish our linked data on the web? Typically, there are the following 4 different ways to do that. First of all, of course, you can publish your data as a huge file, so as a huge dump file, for example, of RDF triples. This might not always be the best way to do it, but at least it's available and people can use it. If you want to make this, or if you want to provide your data in a more comfortable setting for users, then, for example, present them in a SPARQL endpoint, because then they can really access this web service. SPARQL is a RESTful web service, as you know, and can directly ask the SPARQL endpoint and make sophisticated queries on that SPARQL endpoint. Definitely there is also the way, of course, to provide dereferenceable URIs with the help of content negotiation. You know, applications, for example, want with the same URI have either RDF, or a human might have, on the other hand, HTML. And of course, you can also put your linked data into HTML pages. We have talked about that. Therefore, you can use RDFA. We have already covered these topics. So these are the 4 principal ways how you can publish your data on the web. Let's look at these points in a bit more detail. Okay, here you see several options and workflows of possible linked data publishing. So we have to consider either our basic data that we want to publish is structured data, or, for example, we might also have textual data. Text means we have data that is represented as natural language encoded in text. Text and structured data, 2 different things. Of course, first you have to prepare your data, which means, for example, if you have structured data and your structured data is available as a CSV, a comma-separated value file, or as XML or Excel, there are generic converters which convert exactly these kind of data structures into RDF, and of course then you should use it. On the other hand, whenever you have only text, then of course you have to identify the knowledge that is in the text. For this, there is a technique called entity linking or entity extraction. We will talk about that in the next lecture, in lecture 6, when we talk about more advanced applications based on linked data. So there is a tool here, for example, they use OpenCalais. And this is a tool which identifies in a natural language sentence what are the entities represented in that sentence, and, for example, connect these entities, annotate these entities with their DBpedia counterpart. So therefore, this is then annotated text. For this you need a so-called entity extractor. So this would be 2 different ways to prepare data. Either you have structured data as CSV or as, for example, Excel data, or on the other hand, you have natural language text data. Okay, then this data usually is stored somehow. So for example, you have relational databases with structured data, or you have a data source which provides an API, and you have the interfaces then an API to that original data source, or then you have an RDF store, native RDF store, which you can query with SPARQL, or of course you can have RDF files, which are the dump files I have talked about. So what to do in these situations? So linked data can be available exactly in these forms, also in a relational database. Then it's not linked data, it's relational data. But as you see in the next layer, in the data publication layer, if you're looking at relational databases, there are tools where relational data is automatically converted into linked data. Of course, this is not always really sophisticated and does really provide lots of meaning to the text, because there is only a generic way how to, for example, substitute a row and a column and of course then a field in that table into an RDF fact. And of course you have to provide mappings and all the stuff that you can provide an ontology which is connected exactly to the data. But there are already available tools. They are usually called RDB to RDF wrappers. So for example, D2R is one of those tools. And this is a tool that you directly plug in or put on top of a relational database. And the output then will be linked data. But of course, you have to provide mappings to vocabularies and stuff like that to make sense of that. On the other hand, you can also use a content management system, like for example, Drupal, which automatically also provides the possibility to encode RDFA inside their HTML pages. So this is also another possibility where the basic data is available in a relational database, but you have tools on top of that. Either you have these RDB to RDF wrapper, or you have a content management system which provides RDFA output like Drupal, which then converts part of the data into linked data, and you can consume this linked data on the web. If your original data source is a data source which only provides an API, then usually you need a custom-made linked data wrapper. You have to write your own data wrapper, which on the one hand is an import or export filter, or both in both ways, that converts the data from this API to link data. So this is then a custom-made converter that is necessary in that case. If you have your data already available in an RDF store, you might think, for example, to put a nice web interface on top of that. So for example, if you access these DBpedia pages that you have seen, there is also a linked data interface, similar like that one that is mentioned here. Here it's called Puppy. That was the old interface for DBpedia. Now they have a new one. But this does nothing else than simply to arrange linked data in a specific way that as a human in an HTML page, you will be able to grasp the information in a, let's say, more or less convenient way. So this is simply for creating a nice user interface for that. And of course, what you also can do, if you provide RDF files, then you can connect these RDF files in addition to your files that have an HTML representation of exactly this data to your web server, like for example an Apache web server. And this web server can then provide content negotiation. We have also heard about that, and can then switch between either to deliver RDF or to deliver HTML. So this is then something which is connected to content negotiation. So these are the different workflows, the generic workflows that are possible in linked data publishing. If you are interested in these in more detail, please follow the given link. Okay, so now let's look a bit more detailed into the native publication of linked data. So one nice thing to have is, of course, triple stores, which means SPARQL endpoints. And there are lots of available SPARQL server software. So for example, OpenLink Virtuoso, Sesame or Fuseki are only a few examples of the many available endpoints that are there. We have to remember that SPARQL endpoints are so-called RESTful web services, which means with a simple HTTP GET request, you deliver your SPARQL query to the server. And the result, of course, can be in different formats. So, for example, if you have a SPARQL select or a SPARQL ask query, then the result might be XML, JSON, or plain text. If you have a SPARQL describe or SPARQL construct, the result will be native RDF, which means RDF XML, N-triples, Turtle, N3, or any other format that is available on that SPARQL endpoint. And to determine which format should be delivered back, you simply write or use the appropriate accept header that you send in your HTTP GET request to the SPARQL server. But we have already talked about that. This is only a repetition of the already learned facts how to deal with the SPARQL endpoint. Okay, on top of your SPARQL endpoint, you can put one of these linked data interfaces we have talked about. So here you see, for example, this Puppy interface, and you also have a link to this Puppy interface, which does nothing else than, of course, access the triple store via SPARQL, but on the other hand, provides two interfaces, an HTML interface and a linked data interface, that then in the end delivers data in HTML or in RDF for the applications which make use of the data. So for the HTML browser, of course, HTML will be delivered by Puppy, or then to an application, then RDF in any RDF encoding that is available will be delivered via Puppy. So usually this means you are accessing a URI and you give in via content negotiation what kind of encoding you wish, and Puppy then can decide what to deliver. So this is one possibility. Another possibility would be these D2R servers. So here it's about translating non-RDF databases into RDF. Usually these are split these D2R servers in these engines. One is D2RQ, for example. You can look it also up. This application D2RQ, this engine, via this URL that is given here. And this usually then provides a triple store or a RDF dump of your non-RDF database and is connected to a D2R server, which provides then either access to your non-RDF database via SPARQL. So this D2R server translates SPARQL queries into then SQL queries, SQL queries, for example. Then linked data clients will be provided with RDF data, or HTML browsers will be provided with HTML. So there are different possibilities how this works. And here you see also that this D2RQ engine has a D2RQ mapping file, and in this mapping file, of course, there stands what data is encoded with which vocabulary and in which way, so which kind of entities are mapped to the entities which are in your local database. So this can be achieved with these so-called D2R servers. So now you have seen several ways how we can, in theory, publish linked data. Next, we want to talk about best practices. So are there any constraints that should be considered? Are there any lessons learned while publishing linked data?